Today we're going to talk about section 1.2 over linear and rational equations. Our goals today are to solve linear equations, so we're going to talk about inverse operations and what it means for an equation to be considered linear. Then we're going to solve rational equations, and in order to do that we need to find what we call the least common denominator of both numbers as well as polynomial denominators. The way that I'm going to teach you how to solve rational equations is going to be a little bit different than what my math lab is going to show you if you use the ask for help button. So just be aware of that when you go to do your homework. If you ask for help on the rational equation problems, you are going to see a different process. So a linear equation is any equation whose variable is singular, meaning its exponent is a 1. You can have multiple variables in the equation, but it has multiple terms that have variables in them in the equation, but in order for it to be a linear equation that we can solve, all of those variables have to be the same. This is what we call standard form for a linear equation. Standard form is when we set our equations equal to 0 and we have them in a specific form. So in standard form for a linear equation, A and B are going to be numbers, X represents our variable, and as stated before, that variable does not have to be X. So you'll notice that our X term here is singular. It has an exponent of 1. So all of these equations are considered to be linear because all of them have singular variable terms in them. This equation down here, we've got multiple X terms, but that's okay because they are still X. And all of these could be rewritten in AX plus B equals 0 form. So I could move this term over there, this term over there, and so on and so forth. All equations that you're going to solve have a process. The first thing you have to be able to identify is what type of equation it is so that you know what process to follow. So this is the process I follow whenever I'm trying to solve a linear equation. Linear, remember, means singular x's. So first we want to use the distributive property. So if the distributive property is present, we have to do it. No matter how many times it's there, we have to be able to distribute. When we distribute, that will give us the real terms that we are working with in our equation so that we know what to do with them. Then we're going to combine like terms. That's like taking 2x and 3x and making it 5x. So you're making sure that on each side of the equal sign, your expression is as condensed as it can get. So combine number terms on the same side, combine variable terms on the same side, because then we're going to move our variable terms to one side using addition or subtraction. So we want to make sure that all of our variable terms get together. You can move them to the left or to the right, but you will always be using either addition or subtraction to do that. If the term is positive on the right side, then you have to use subtraction, the opposite of it, to get it to the left side, and vice versa. We will then solve equations using inverse operations and check your answer. So inverse operations are things like multiplication and division, and addition and subtraction. When you're dealing with multiplication and division, you want your inverse operations to equal a value of 1. When you're doing inverse operations for addition and subtraction, you want those to equal a value of 0. So all of these examples are linear equations. All of them have, I've chosen x's, and all of those x's have an exponent of 1. So step 1, distributive property. There is none there. Step 2, combine like terms. Well, 4x plus 5, those are not like terms, so I can't combine them by addition. They have to stay two separate terms. Next step is to get your variable terms all on one side. Well, my variable terms are all over here on the left. I only have one of them. So my goal is to get this isolated first. So that means I want to get rid of this plus 5. The opposite of plus 5 is minus 5. The rule of equations is whatever I do to one side, I have to do to the other side. And when I subtract 5 from here, it cancels. When I subtract 5 on the right, 29 minus 5 gives me 24. Now I want to solve for x here. This 4 is my coefficient, which means it's being multiplied. So the opposite of multiplication is division. So x will equal the value of 6. We can always check our answer by plugging in the value for our variable into our equation and making sure that the left side and the right side are in fact equivalent. 24 plus 5 does in fact equal 29. And since 29 equals 29, we have proven that x does equal 6 in this equation. This next one here, same type of problem. It's linear because here's my x. I want to solve for x, so there's no distributive property. There's no combining like terms because 2/3 x and 1/4. One's a variable term, one's a number. All of my variables are already on the left-hand side, which means I want to move this negative 1/4 that I'm subtracting over here to the right. So the opposite of minus 1/4 is plus 1/4. Those will equal 0, which is what I want. And I have to add 1/4 to the other side. So I have 2/3 x on the left, and I have 5/6 plus 1/4 on the right. Now, in order for us to add those, I need to have a common denominator. In this case, both 6 and 4 can be changed to the multiple of 12. 6 will multiply by 2 to get 12, so 10 has to multiply by 2 to get an equivalent equation of 10/12, or equivalent fraction, sorry. 4 can multiply by 3 to get 12, so 1 also has to multiply by 3 to get an equivalent fraction of 3/12. I add those together, 10/12 plus 3/12 means I have 13/12. Now I want to get rid of the 2/3 that is being multiplied. The problem here is that we learned the other day that when I divide by 2/3, which is what I would have to do here, to divide by a fraction, you change it to multiplication by the reciprocal. So I'm not going to divide here because dividing by 2/3 means I multiply by 3/2. And when I multiply something by its reciprocal, it does equal 1, which is what I want for the inverse operations. So if I'm multiplying the left side by 3/2, I also have to multiply the right side by 3/2 to keep my equations equivalent. So 3/2 times 2/3 cancels out, leaves me with just x. And here I need to multiply my fractions together. You can either multiply across and reduce. That will give me 39/24, which then I can divide by a common factor of 3. And I will get 13/8. The other way you could do that would be to cross cancel. So if I cross cancel, 3 divided by 3 is 1, 12 divided by 3 is 4, and I get 13/8 that way as well. Either way is fine as long as your answer is left in reduced fraction form. Question 3, or example 3. This is the first linear equation where I do have distributive property. So I need to distribute the 4 into 2x plus 1, which gives me 8x plus 4. On the other side, 29 is not part of my distributive property. The plus 3 is what is distributing into 2x minus 5, and that gives me 6x minus 15. Second step, combine like terms. 8x plus 4, that expression is as simplified as it can get. But on the right, 29 and negative 15 can condense because they are numbers, so I can combine them into one number term, and I get 6x plus 14. Third step, make sure all variables are together. Well, I have a variable term on the left and a variable term on the right. They are both positive in their places right now, so that means I will be subtracting them. I always try to move the smaller one, so I'm going to move this 6x, so I'm going to subtract it. 6x minus 6x will cancel it out there. I will subtract 6x over here, and I get 2x plus 4 equals 14. Now all my variables are on the left, so I need to move this plus 4 to the right, so I'll subtract it. So 2x will equal 10, and then the opposite of multiplying by 2 is dividing by 2. I have to do that to both sides, so x would equal 5. Again, both of these we could check our answers by putting in our x values into our variable here. In this equation, 5 would have to go into both x terms. I could do many different examples. They're all going to follow the same process. Every single linear equation will follow that exact process. I want you to remember this date. That is my husband's birthday. Just remember that for future. All right, the second type of equation today is rational equations, and that is why we looked at what rational expressions were the other day and how we can simplify them a little bit. A rational equation is technically any equation that has a fraction in it. So technically over here we could have looked at this one as a rational equation. I would have had to write it a little bit differently, but I could have looked at this as a rational equation. But because my coefficient, the fraction, is pulled out in front of the x, we look at it more as a linear equation. When we talk about rational equations, we're talking about equations that have polynomials within the numerators and the denominators of those fractions. Again, we don't have to worry about standard form because we're going to solve them in whatever form they are in. But as long as I have a polynomial fraction expression, it's going to go into the rational expression or rational equation category. And like I said earlier, the way I teach you this is going to be a little bit different than the way my math lab will do this. So to solve a rational equation in my method, the first thing I'm going to do is find a common denominator, the LCD, the least common denominator. We're going to have to factor whether they're numbers or polynomials to do this. It's going to look a little different if the denominators are all numbers compared to if they're all polynomials, but we're going to look at examples so I can show you how to do that. We know that if we change the denominator of a fraction, we also have to change the numerator of a fraction to keep it equivalent. So we're then going to determine what do I have to multiply the denominator by, and that will tell me what I have to multiply the numerator by so that I get a new equivalent fraction. Once I do this step, I'm going to get rid of my denominators and I will solve the remaining equation. This will be a linear equation. Then we have to check our answers. That doesn't mean we check it back into our original. It means we have to check it with our excluded values. If a solution we get in step 4 for our x matches an excluded value that x cannot be, if these two match, then we actually have no solution to our equation. And this solution is what we call an extraneous solution. It works when we solve it algebraically, but then when we go to check it, it's not actually gonna work. So the problem is a lot of times they will ask you for those excluded values, so we have to remember to make sure we do that. So we're going to look at, I think, 3, maybe 4 examples of these. So here's our first one. Step 1, we need to find our common denominator. I said you may have to factor to do that. So I'm going to take each one of these denominators and I'm going to factor them. 2x is the product of 2 times x. 18 is the product of 3 and 6, and 6 breaks up into 2 and 3. So I've got a factor of 2 times 3 times 3. That's going to give me 18. And 3x is 3 times x. What I'm going to do with these is I'm going to make an LCD list. I need to have the factors of each one of these denominators in my LCD. So I'm going to start with my first one. To make up the denominator of 2x, I need a factor of 2 and x. To make up the denominator of 18, I need a factor of 2, 3, and 3. Well, I already have that factor of 2 in this list, so I only need to add the factors of 3 and 3. To form the denominator of 3x, I need the factor of 3 and x. Since all of these are monomial factors or monomial denominators, I'm actually going to multiply these together and get 18x. That becomes my new denominator. So every single part of my fraction, whether it starts as a fraction or not, or every single part of my equation, has to take on that new denominator of 18x. My job is to figure out if this changes to 18x, what does this have to change to? And this have to change to? And that have to change to? So I think we can all agree that 2x times 9 gives us 18x. So 5 times 9 will give us 45. These two rational expressions are equivalent. We just multiplied them by the common multiple of 9. Well, 18 had to multiply by x, so 17 will multiply by x, so we would get 17x here. And 3x had to multiply by 6, so 1 times 6 gives me 6 over 18x. Once I have a new equation where all parts of it have a common denominator and my numerators have been changed to what they need to be equivalent, now I can drop my denominator and solve the equation that is formed by my numerators. This is a simple linear equation. No distributive property, no combining my terms. My variables are on the right, so I'm going to move the -6 over to the left by addition. I get 51 equals 17x. 17 is multiplying by x, so the inverse of multiplication is division when it's a whole number. So x can equal 3. Now, if we go back up to my original problem, I do have some excluded values. In this denominator of 2x, if I plugged in a 0, 2 times 0 would give me 0. Same thing here. So my only excluded value is that x equals 0. Since this doesn't match, we are hoping that that will work. You could check your answer by plugging it into your x's and make sure that both sides are equal. The next one here. We still have a 3-term equation here. However, this term is not a fraction yet. We're going to make it a fraction, because I need to make sure that when I make it a fraction, or that when I'm using the method that I use, every single term in my equation has the common denominator. This denominator is a little bit easier to find because they're only numbers. So the common denominator between 2, 1, and 3 is going to be 6. So I'm going to make all terms have a denominator of 6. Now, because my numerator, my dog's coming in, so you'll hear him, sorry. Since my numerator are larger polynomials than one term, I'm going to write them down so that I can figure out what I have to multiply those numerators by, because it's going to involve the distributive property. So 2 times 3 gives me 6, so x plus 5 will also multiply by 3. 1 times 6 gives me 6, so 4 is going to multiply by 6. And 3 has to multiply by 2 to get 6, so 2x minus 1 is going to multiply by 2. All of my denominators are now the same. I know what I have to multiply my numerators by, so I'm solving 3 times x plus 5 minus 24 equals, 2 times 2x minus 1. And then I can solve this linear equation. I have the distributive property, so I'm going to get 3x plus 15 minus 24 equals 4x minus 4. I'm going to combine my like terms here, and I believe I get 9 minus 9 equals 4x minus 4. I've got a x term on the left and the right. I'm going to subtract the 3x because that's the smaller one. So I'm left with negative 9 equals x minus 4. So I'm going to add 4 to both sides, and x can equal negative 5. Okay. Now that might not be the same example you have in your homework or in your notes, and that's okay. Just make sure that you take note of this one. Now this one has no excluded values because my denominator does not have any variables in it. Okay, I knew something wasn't working out there, so I paused you guys for a minute and then I went and checked it out. I screwed up here when I distributed here. So this should be 4x minus 2, which gets me here. So when I subtract, I have negative 9 equals x minus 2. And when I add 2 here, I should get negative 7. Okay, sorry about that. On to our next one. This is the first one where my denominators are not monomial terms or numbers. So to find our LCD, it's going to look a little different. We're still going to factor, but instead of actually multiplying those factors together to get a monomial term on the bottom, we're going to have a list of common factors on the bottom. Okay, so this denominator has a factor of x plus 3. It does not factor anymore. That means no matter what, even if I was multiplying, every single denominator would have to have a factor of x plus 3 in it. The next denominator of 2x plus 6 factors into 2 times x plus 3. So that means I need to have those two factors in my common denominator. I already have the x plus 3 from here, so I'm going to drop that 2 into my common denominator. My last denominator is a factor of x minus 2. I don't have that in my denominator, so I'm going to put it in there. Okay. Now, none of my denominators contained all three of these factors. That means the numerator of 3, 5, and 1, they're going to have to multiply by something. We're going to figure out what was already there in the original expression, and then what did we add to it in the new expression. So we started with 3 over x plus 3. That means to my original denominator of x plus 3, I multiplied it by 2 and x minus 2. So that means the top has to get multiplied by that. 5 was over the factors of 2 and x plus 3. To those factors, I put in the factor of x minus 2. So 5 is going to multiply by x minus 2. 1 was over x minus 2. 1 over x minus 2. To this denominator, I multiplied it by 2 and x plus 3. So I'm going to do that to the top. Now I can drop those denominators, and I'm solving 6 times x minus 2 equals 5 times x minus 2 plus 2 times x plus 3. And I can go ahead and then solve that linear equation. So I need to distribute. I get 6, I'm thinking ahead. 6x minus 12 equals 5x minus 10 plus 2x plus 3. 2x plus 6. Goodness gracious, this is what happens when you spend all day in the pool. All right. Combine like terms. The expression on the left is combined. The expression on the right is not. 5x and 2x does give me 7x. Negative 10 and positive 6. If I have $10 and I spend 6 of it, I still have negative $4. Want to get my variable terms together, so I'm going to move the 6x again because it's smaller, and that will allow me to eliminate having to deal with negatives with my x term. I have negative 12 equals x minus 4. And then I can add 4 to get my x alone on the right-hand side. So x equals negative 8. This does have some excluded values. Here, x cannot equal negative 3. 2x plus 6, which means 2 times x plus 3, that would still be a negative 3. And here, positive 2. So since my excluded values and my possible solution for x don't match, I'm good. And I can go ahead and check my answer and make sure that it works out. And one more. Again, I have a factor of x plus 2. So that has to go into my common denominator. This denominator is made up of the factor x minus 2. I don't have that, so I need to put that into my common denominator. And x squared minus 4 factors into x plus 2 and x minus 2 because of the difference of two perfect squares. So I already have those, which means this is my common denominator, which means my numerator of 12 will not change. But 5, since it started over x plus 2, we'll have to multiply by x minus 2. Since 3 started over x minus 2, it's going to have to multiply by x plus 2. Cross out my denominator, and I'm left with 5 times x minus 2 plus 3 times x plus 2. That's my dog again. Equals 12. Solve the linear equation. I'm left with 5x minus 10 plus 3x plus 6. Look at that. I got that right on the first try. I need to combine like terms, so if I have 5x's and 3x's, that means I have 8x's. Negative 10 and positive 6 still means I have negative 4. My x's are all over here on the left, so I'm going to add 4. So 8x equals 16, and I can divide by 8, which means x equals 2. If I go back up here, state my excluded values, x cannot equal -2 because that makes this and this 0. X can also not be +2. Well, if x can't be +2, but my only possibility for x is 2, that means this is an extraneous solution, and this equation has no solution, or it's said to have an empty set.